Hello everyone, welcome to Prochem Academy. Today I will start a new chapter of class 10 ICSC, that is study of compounds. And here I will start the hydrogen chloride first. So here we know about hydrogen chloride, that hydrogen chloride is a gas and its formula, molecular formula, is HCl and its molecular mass is 36.5 because atomic mass of hydrogen is 1 and for chlorine 35.5, so it is 36.5. okay, and it can form by the combination of hydrogen and chlorine. Now what is the history of this hydrogen chloride, how it formed, how it came? Okay, first of all, in 1648 a scientist was there whose name is Glauber, first formed the HCl, prepared the HCl just by heating a rock salt, that means a common salt with concentrated sulfuric acid, and that is the first HCl formation, that is the first HCl preparation. After that, in 1772 Joseph Priestley was prepared the HCl gas by same method was done by Glauber, but he has collected that gas, that means Joseph Priestley collected the gas on dry and pure mercury. Okay, and after that he has named the gas as marine acid because that solution he has named as marine acid. After that, after some few years, Lavoisier changed the name of that HCl as muriatic acid, changed the name as marine from muriatic acid. Okay, he has changed the name as muriatic acid. And after that, in 1810, Humphrey Davy was told that the compound HCl was the mixture of hydrogen and chlorine. It is a combination of hydrogen and chlorine. Okay. Now, what is the occurrence of this HCl gas? HCl can be found in atmosphere by volcanic eruption, okay, and also in the gastric juice of the mammals. It is the occurrence of HCl in nature. Now we will see how this HCl can be, what is the bonding of this HCl, what is the Lewis-Dot structure of this HCl, how it can be formed, and what kind of bond is there. So here by the electron dot structure we can easily say here hydrogen having 1 electron and chlorine having 17 electron, and its electronic configuration is 2, 8, 7. Now that means hydrogen having only 1 electron in its outermost shell and chlorine having 7 electron in its outermost shell. Now these will participate in the formation of bond, okay, so that the hydrogen, if it has 2 electron, then it will be stable, and if chlorine has 7 electron, it will be stable. Sorry, 8 electron, it will be stable. So here it is forming one bond, that is HCl. So HCl is a single bonded compound and covalent compound. Okay, now we have done this, what is the history, how it came actually, what is the molecular formula of HCl, molecular mass of what is HCl, and its formation, Lewis-Dot structure or electron dot structure. Electron dot structure. Now we will see how it can be prepared. General method of preparation. General method of preparation. Now HCl can be easily prepared by heating a rock salt, that means a common salt with sulfuric acid. General method of preparation of HCl gas. How we can prepare? We can take sodium chloride, and if you treat this one with concentrated sulfuric acid at below 200 degrees centigrade temperature, then you will get a sodium sulfate with HCl, sodium hydrogen sulfate with HCl. Again, it can be done with greater than 200 degrees centigrade temperature. Then again, but here this sodium sulfate will be formed with HCl, Na2SO4 with HCl. Now we can take other chloride also, like magnesium chloride. Like magnesium chloride, if you take with concentrate sulfuric acid, then you will get by heating we will get magnesium sulfate with HCl. We have to do the balance here. And also if you take copper chloride with concentrated sulfuric acid, copper chloride, these are the methods of preparation. Copper sulfate plus HCl. But from these four, we will only use as a laboratory preparation these two, that means sodium chloride and concentrated sulfuric acid, because sodium chloride is easily available in the laboratory, and it is not much cost. It is not much costly, so we can easily get sodium chloride. And for laboratory preparation, we will use concentrated sulfuric acid, not other acids, because it is a non-volatile and its boiling point is very high. So why we will use in the laboratory preparation this sodium chloride and concentrated sulfuric acid? The reason behind this, sodium chloride is easily available and it is not much costly, and concentrated sulfuric acid is a non-volatile acid and its boiling point is very high. So in laboratory preparation, we will take sodium chloride and concentrated sulfuric acid. Sodium chloride and concentrated sulfuric acid. Now, what is the reason behind this concentrated sulfuric acid? Why we will take? Because it is non-volatile and high boiling point. It has high boiling point, non-volatile nature and high boiling point. And here sodium chloride less costly, not much high cost is there, and with that it is easily available. It is easily available. Okay, so these are the two reasons why we will use this sodium chloride and concentrated sulfuric acid. Now to prepare this, we have to use some apparatus such that we have to take a round bottom flask like this. We have to take a round bottom flask. And here we have to take sodium chloride, pinch of sodium chloride, and here we have to add by a Thesel funnel. We have to add concentrated sulfuric acid. We have to add concentrated sulfuric acid here by this Thesel funnel, concentrated sulfuric acid. Now after that we have to heat this one. Okay, now we have to heat like that so that the temperature should not be exceed that 200 degree centigrade temperature. We have to heat up to below 200 degree centigrade temperature, not more than 200 degree centigrade temperature. Because if you give the heat more than 200 centigrade temperature, then that sodium hydrogen sulfide will not form, but sodium sulfate will form. Okay, so we cannot increase the temperature more than 200 degree centigrade. It should be less than 200 degree centigrade temperature. Okay, so after heating we will get a HCl gas, which is bubble through here. HCl gas we will get, but it is moisture will be there with it. That means moist HCl gas. Moist with HCl gas we will get here, because this sulfuric acid consists of 2% of water. 1 mole of sulfuric acid consists of 2% of water. So the HCl gas we will get from here, that means sodium chloride with concentrated sulfuric acid. The temperature should be less than 200 degree centigrade temperature. Then we will get sodium hydrogen sulfate, that means sodium bisulfate with HCl gas. Now this HCl gas will consist of moisture, and we have to dry this one. We have to dry this HCl gas, and we have to now how we can dry this HCl gas? By adding sulfuric acid. So this HCl gas which will go by this tube, and we have to take in a gas jar. This HCl gas, which will be moist HCl gas, and we have to add sulfuric acid here. moist HCl gas is here, and in that we will add sulfuric acid, concentrated sulfuric acid. Now this concentrated sulfuric acid with HCl, this concentrated sulfuric acid will take all the moisture here, because it is a dehydrating agent. It will dry this one. This concentrated sulfuric acid will dry this HCl to prepare dry HCl gas. Dry HCl gas. Now this dry HCl gas will be collected over upper displacement of air. We cannot use the we cannot collect this HCl over water, because HCl is very dissolved in water. It can be rapidly dissolved in water and very much soluble. So we cannot collect this HCl, dry HCl gas over water. We have to collect over air displacement, upper displacement of the air. Now in this gasture we will get dry HCl gas. Okay, now what is the reason behind this use of concentrated H2SO4? Because this can easily dehydrate the moisture present in the HCl gas. Okay, so that we will get a dry HCl. Okay, so now the gas formed here in the gas chamber, dry HCl, this HCl is HCl or not, we have to make sure that this HCl or not, because this gas is HCl gas is normally colorless, so we have to show by a test. We have to do a test so that this is HCl or not. We have to make sure. Now what we will do, we will take a glass rod. We will take a glass rod which will be dipped into the ammonia solution. That means ammonium hydroxide. Now the glass rod which is dipped in this ammonium hydroxide, that will be kept on HCl gas jar. Now what will happen, we will see a dense fume on white fume will form on the side of the glass rod, because this ammonia, when it get touched with this HCl, it will form ammonium chloride, which is dense white color. So by this confirmatory test we can confirm that this dry HCl will be this is a dry HCl gas, that means hydrogen chloride gas. So this is the overall laboratory preparation. Okay, now some questions can arise from here, that why HCl gas is collected over air, not the water, because HCl can easily dissolve in water. So that is done. Now why the temperature should not exceed 200 degree centigrade temperature? Because if it is 200 degree centigrade temperature, if we give more than 200 degree centigrade temperature, then here it will form sodium sulfate with HCl. Now this sodium sulfate can be easily break down in this gas jar. So that gas jar or this round bottom flask cannot be used again. So we cannot use this heat more temperature, or here the round bottom flask can be broken also by taking more temperature, more heating. So it should be less than 200 degree centigrade temperature. So this is the overall preparation, and this is the method for how we can collect this gas. Okay, and how we can confirm. This is the confirmatory test. Okay, now we have done. Now in next video we will discuss about some other reactions of HCl, how we can prepare HCl, some other reactions. Now if you want to see the properties of HCl gas, HCl is a colorless gas, having it is very much dissolved in water, and it is having some kind of pungent smell. Okay, so these are the properties of HCl. So in next video class we will discuss about some reactions of HCl, and one preparation already we have done, so some reactions are left. So those reactions we will discuss in the next video class. Okay, so if you like this video, then do like, comment and subscribe my channel, so that I can make more videos on that. So stay tuned. Next day I will make another video on reactions of HCl. Okay.